So a DC motor, a device which converts the electrical energy to kinetic energy, that is known as a DC motor. So what is the concept, how it works? The basic idea is that, like example, this is how a DC motor looks like. What we have in a DC motor, the labels, we have a permanent magnet. A permanent magnet, north and south poles are there, as you can see on the image. Then we have a rectangular coil. This one is a rectangular coil. Then we have the split ring. In a AC generator, we use slip rings, but here these rings are breakdown. So that's why we call them as a split ring. So X and Y are the split rings, and we have a supply. So what is the energy change here when we pass the current? So input is the electrical energy. So when we pass the current, the rectangular coil or the wires start to rotate, it turn into or change to kinetic energy. But how the electrical energy can be changed into kinetic energy? So if I consider the direction of the flow, example, as you can see, the battery, the right hand side of this battery or a supply is positive and the left hand side is negative. So what will be the direction? So what is the direction of the flow of the current? The conventional current will move. So it will move through
clockwise.
Yeah, first it will move through this. So first, this is the direction of the current. Now, after knowing the direction of the current, we want to find the direction in which this coil will rotate. How we can work out the direction of the rotation of the coil? We have to use a rule here whenever we are finding a force on a wire when a place in a magnetic field. So we use the Fleming's left-hand rule. According to Fleming's left-hand rule, the index finger, the first finger should always point towards the south. The second finger represents the direction of the current and thumb is pointing in the direction of force. So when you see the first figure, side A and B. So for side A and B, when I try to apply a Fleming's left-hand rule, so my index finger should point towards south. So index finger is pointing towards the south. My second finger represents the direction of the current. So direction of the current is from A to B. So that is into where thumb is pointing, the direction in which the thumb is pointing, that is a force. So for side AB, it will experience the force downward. And when we apply the Fleming's left-hand rule for side C and D, the direction of the current is different from C and D. It is out. So my index finger point towards the south. That is towards the right-hand side. My second finger is pointing in the direction of the current, which is coming out of the paper or screen. And where my thumb is pointing, that is a force. So my thumb is pointing up. So it means the direction of the force is upward. So C and D is experiencing a force upward and A and B is experiencing a force downward. So example, if this is a coil, one side it is experiencing a downward force and the other side it is experiencing an upward force. So if this coil is on the axle, one side there's a downward force and another side there's an upward force. So what will happen? This coil will turn or it will rotate. What is the application of a DC motor? We can use all, like example, electrical fans, juicers, mixers, all these are actually DC motor. They work on the principle that when we pass the current, it produces a magnetic field which cuts the magnetic field of a permanent magnet and experience a force. So when we are passing a current, so from A to B, then from C to D, so due to the direction of the force on A and B, it is downward, and C and D, it is upward. So what will happen? This coil will experience the force. As a result, when this coil will experience the force, it will rotate between the poles of a magnet. And where we can use this effect, like electric fans, when we switch on, the fans start to rotate. Why it rotate? Because when we pass the current, there is a magnetic field due to a current, and there is a permanent magnetic field which is produced. Both cuts interact each other. As a result, the fan or the coil will start to rotate. So any device, any machine which use a rotation by passing a current is based on the principle of DC motor. For example, if we want to find the direction of the force for this wire, rectangular wire which is placed in a magnetic field, so we have to use a conventional current. So conventional current is from positive to negative. So for this cell, so a cell or a battery, this left hand side, this one is a positive terminal, the other one is negative. Now the conventional current, the current start to flow from positive to negative. So it will pass through the split ring, then it will go into, and then it will return back. So if we want to find the direction of the force, if I say this one is side A, this one is A, so this side is A, the other side is B, and this one is C, and the other side is D. If you want to find the direction of the force on side AB, so to find the direction of the force on side AB, my index finger should point towards the south, which is on the right hand side. AB, the current is going into, it's from A to B, so index finger is pointing towards south. The second finger is representing a direction of a current from A to B, and my thumb is pointing downward. So as a result, what will happen? There will be a downward force on side AB. And what about the force on side CD? Again, I will use the left hand rule. My index finger is pointing towards south. My second finger is pointing in the direction of a current, because for C and D, the current is out. Where my thumb is pointing, that is a force. So as a result, there will be a force upward. So there is a downward force from AB and upward force from C and D. As a result, what will happen? This coil will start to rotate. And it will rotate continuously. But when the coil will lose the contact, as you can see in between, it loses the contact. So once it loses the contact, now there is no more current. But the coil will continue to move. Why this coil will continue to move? Because of its inertia. So like example, when you switch off the fan, instantly the fan does not stop moving. It will continue to move some time because of its inertia. So same thing happened for this coil, that when the coil is rotating, when it is in contact, the current is passing, it experiences a force. When it is vertical, there is no current passing through a coil, as there is no connection, no contact, but still the coil will continue to move because of its inertia. And continuously it repeats its cycle. So to find the force, we always use a left hand rule. And how to know the direction of the current? Direction of the conventional current is always from positive to negative. Like here, see, we have two split rings. One is X, another one is Y. So this one is split ring X, and the other one is split ring Y. Now we want to find the direction of the current. What will be the direction of the current? The direction of the current is always from positive to negative. How to identify which terminal is positive? So the big line always representing a positive terminal of a cell, and the small line is a negative. So the direction of the conventional current, it is always from positive to negative. So current start to flow. It will flow through Y and then passes from A to B, then from B to C, then from C to D, and then it will return back. As a result, when there is a current from A to B, what will be the direction of the force when we apply the Fleming's left hand rule? The index finger is pointing towards the south. So the index finger is pointing towards the south. The second finger is representing a direction of a current, and my thumb is pointing downward. So the force on side AB, that will be downward. And what about the force on side C and D? Again, I will use a left hand. Always we use a left hand to find the force on the wire, which is placed in a magnetic field. So index finger is pointing towards south, second finger is representing direction of a current, and thumb is pointing upward. So the direction of the force for side C and D is upward. So what will be the direction of rotation? What will happen? If we have a coil, one side there's a downward force, other side there's an upward force, so it will start to rotate. But when it's rotate, the coil will lose the contact. So it will start to rotate in a clockwise direction. When we change, when the coil is exactly vertical, now there is no more current passing, as you can see. Now the coil is vertical. As it is vertical, there is no current passing through. So if there is no current passing through, it will not experience the force, but it will not stop rotating. Why it does not stop rotating? Because, like as you can see, this is X, the split ring X and the split ring Y. So split ring X and Y, now they are not in contact. There is a gap between the carbon brushes and the split ring. So as there is a gap between them, the circuit is not complete. As a circuit is not complete, there is no more current passing through this rectangular coil. As there is no current, it will not experience any force due to a magnetic field. As this wire, it was rotating, so it will continue to move because of its inertia. And then it will return back to the horizontal position. So now it is at horizontal position. So X is on the side, right hand side, and Y is on the left hand side. So when X is on the right hand side and Y is on the left hand side, the ends also changes. Like if you see the first figure, this was the first figure, that X was on the left hand side, Y was on the right hand side, and the sides were CD were on the left hand side and AB on the right. When we pass the current, it cuts the magnetic field and experience the force and start to rotate. First it will be vertical and then it will be horizontal back again. When it is horizontal back again, now the sides has changed. In the beginning, AB was on the right hand side, now AB is on the left hand side. And C and D was on the left hand side in the beginning, now C and D is on the right hand side. But it will not stop rotating. Now what will happen? The current, now it is in contact, so current start to flow. So the conventional current will always move from positive to negative. So as the conventional current move from positive to negative, so there is a current from D to C and there is a current from B to A. Now to find the direction of the force on C and D, C to D and from B to A, so we will use again the Fleming's left hand rule. According to Fleming's left hand rule, my index finger always point towards the south. So my index finger is pointing on the right hand side, which is the south. My second finger point in the direction of the current. For C and D, the current is going into the screen. So C and D is pointing into. Where my thumb is pointing downward. So as a result, what will happen? This will experience a force downward. So there will be a force downward on C and D. And when we find the force on A and B, the index finger is pointing direction of the magnetic field, which is always towards the south. My second finger is pointing in the direction of the current, which is coming out from the screen or from B to A. And thumb is pointing upward. As a result, there will be an upward force. So what will happen? This coil, again, A and B on the left and C and D on the right. And when it experiences a force from CD downward and AB upward, so it will again flip or rotate. So this is how a simple DC motor works. That whenever there is a current, it experiences a force one side up, another side down. and it rotated. When it is vertical, it does not experience any force because there is no current. And once it again come in contact, it will also experience the force in the same direction. As a result, it will continue to move. So if we connect, like example, if this can be connected to a mixer or a juicer or even a fan, this coil can be connected to a fan, and then the components in the fan will start to rotate. So all the electrical motors, electrical devices which on passing the current rotate, they always have this DC motor. We can also change the speed of the rotation. How we can change the speed of the rotation, and this is very important paragraph, the purpose of the split rings. You will find this question, they ask, state the purpose of the split ring. So this is a complete answer. What is the purpose of the split ring? A split ring reverses the direction of the current. How the split ring reverses the direction of the current? As you can see here, the first image, X is on the left hand side and Y is on the right hand side. So what was the direction of the current? The direction of the current, it is from A to B, then from B to C, then from C to D, and then return back. But as this coil rotated, the split ring changes the contact. Now what is the direction of the current? So the direction of the current is from D to C, then from C to B, and then from B to A. So the direction of the current is reverse. Before it was from A to B, B to C, and C to D, and now it is opposite direction. So what is the advantage of this? That's when the split ring changes the direction of the current every half cycle or after every 180-degree rotation, it ensures that the coil will rotate in a fixed direction, or it will continue to rotate. And if we want to change the speed at which a motor is rotating or the coil is rotating, what we can do, we can increase the current. That's how we are able to change the fan speed. You have find, like example, the regulator of a fan, it shows different speed, like from 1 to 5 or 1 to 4. So actually that regulator for a fan is like a variable resistor. So what we do when we change the level of a resistance, like from 1 to 2 or 2 to 3, it changes the resistance, and when it reduces the resistance, the current increases. As the current increase, there's a greater turning effect, and because of greater turning effect, it will rotate faster. So we can increase the current to increase the turning effect. We can also increase the number of turns of coil. Like as you can see, if we are using only one turn, it will rotate but not fast. What we can do, we can have more turns, like greater length of a wire in a magnetic field. As a result, when we have greater number of coil turns of a wire in a magnetic field, it will experience greater force and it will rotate faster. So if two images are there, like the first one, we have only one turn. The second one, we have 1, 2, and 3 turns. So which one will move faster? On the right hand side, it will move faster because it has more turns, like more greater length of a wire in a magnetic field as compared to the first one. Or we can also increase the strength of a magnetic field. We can use a stronger magnet. Using a stronger magnet, it will experience greater force, or increasing the area of the coil. So if we increase the area of the coil, greater length of or greater area of the coil in the magnetic field, it will experience greater force. And when it experiences greater force, it will rotate faster. So these are the factors which you can change to increase the turning effect. Number one, current. Increase the current, increases the turning effect. Use more turns of wire. Like example, if I have a coil with only one turn and I have another coil with say 2 or 3 turns, so which coil will move faster? The one which is more turns. And if I'm passing 2 ampere of the current and 5 ampere, so 5 ampere The 5 ampere will produce a stronger magnetic field. As a result, it will produce greater magnetic field or experience a greater force. And increasing the or using a stronger magnet, like if I use a magnet with a strength of 3 Tesla, or I use a magnet with a strength of 6 Tesla. So if I'm using a stronger magnet, the wire will experience more force. Same thing for area. If we are using a small surface area and we use a large area of a wire, it will experience more force. So these are the factors which can affect the speed at which the rectangular coil is rotating between the poles of magnet. Now some questions related to DC motor. As you can see, figure 9.2 shows a simple DC motor which is connected to a battery and a switch. So you can see a permanent magnet is there. These are the split ring, and next to split ring are the carbon brushes. There's a battery and a switch. So we have to complete the boxes. So what is this part? This one is a carbon brush. And what about the second part? That is the split ring. Now, if I say what will be the direction of the force, so this one is a split ring. So if I say state the direction of the force, and these are the side, like example A, B, C, and D, or other way around. So this one is A, B, C, and D. Now, how to work out the direction of the force? It is important that you identify the direction of the conventional current, which is always from positive terminal to negative terminal. So this is a positive terminal, so current start to flow out from a positive terminal. What is the purpose of the carbon brushes? Carbon brushes are like a contact made up of graphite. It is a conductor, allow the current to pass through. So current will pass through the carbon brush, then it will pass through split ring, one of the split ring, and then it passes from A to B, then from B to C, and then from C to D, and then it returned back from the other side. Now, if I say state the direction of the force on AB, so how we can work out the direction of the force on A and B? So to find the direction of force on AB, my index finger should point towards the south. So my south is on my right hand side of the figure. So my index finger is pointing towards south. My second finger should point in the direction of the current. So current is going for, this is the magnetic field always pointing towards south. And the second one is representing a direction of the current, which is from A to B. Where my thumb is pointing downward. So it means A and B will experience a force downward. Because sometimes we have to draw an arrow to show the direction of force. In this question, they did not ask, but we can practice. And from C to D, to find the direction of force from C to D, my index finger should point towards south. My second finger is pointing in the direction of the current, which is outward. So the thumb is pointing upward. And it automatically, you can work out, like if one side it is experiencing a downward force, the other side it should experience an upward force. So the direction of the force will be upward for C and D and downward for A and B. The next question, the DC motor is another way to convert the electrical energy to kinetic energy. In a space below, draw a label diagram of DC motor. So you have to draw a label diagram of a DC motor. So what you can do, you can place a magnet north and south. I will draw a 2D. If you're good in drawing, you can draw 3D. So we have a permanent magnet, then a rectangular coil. And with this rectangular coil, we will have a split rings. It should always be label diagram. So we will label all the parts, the split rings, and these split rings are connected to carbon brushes. And after that, we have a supply source of energy, a battery or a cell you can draw. And it should always be labeled like magnet, rectangular coil, split ring, carbon brushes, supply or a source. Then describe how a split ring commutators on an electric motor works, or what is the purpose of the split ring commutators. So what is the purpose? Split ring commutators are connected to carbon brushes connected to the split ring commutators, which rotate the coil and it reverses the direction every half cycle. Like example, what happened? First, left hand side is A, B, C, and D. So the direction of the current, conventional current, is always from positive to negative. So the direction of the current from A to B, then from B to C, and then from C to D, and then return back. Then the next half cycle, what happened? The direction of the current reverses. So this is north, south, and we have a rectangular coil or a rectangular wire, which is placed in a magnetic field. We have the split ring. The difference between the DC motor and AC generator, you can identify from the rings only. In an AC generator, we use slip rings. Slip rings are like circles, and split rings are, the ring is divided into two parts. That's called a split ring. And the direction of the conventional current is from positive to negative. As the coil rotates, the sides will also change. Now this side will be D, this will be C, this one is B, and this one is A, because it rotated. So as a result, when it rotates, it changes the direction. Now, what will be the direction of the conventional current? It is from positive to negative. So the conventional current start to flow from positive to negative. So you can see the direction of the current has changed. First, the direction of the current was from A to B, B to C, and then C to D. But when it rotated 180 degrees, the direction of the current is from D to C, C to B, B to A. So what is the use of the split rings? When the split ring rotate 180 degree, the direction of the current changes in the DC motor. And what is the advantage of changing the direction of the current? That if we work out the direction of the force here, it will be a downward force. On AB and on C and D, it will be upward force. But when C and D is on the left hand side, it will experience a downward force, and AB will experience an upward force. So the direction of the current reverses in according to the coil, and which cause the coil to rotate in one direction or one way. So it will continue to rotate. So another question. A simple DC motor made in a school lab, a coil of a wire is mounted on an axle between the horseshoe magnet. At the instant illustrated in 9.1, a coil ABCD, as you can see ABCD, and a battery is connected. For this purpose, state the direction of the force on AB and the direction of the motion for AB. So how to work out the direction of the force? So we should always use a Fleming's left-hand rule. The conventional current is from positive to negative. So when I draw the direction of the current, it's from positive to negative. So for side AB, it is into. So I have to use a Fleming's left-hand rule. My index finger should point towards the south, which is on my right-hand side. My second finger represents the direction of the current, which is into, from A to B. So where my thumb is pointing for a left hand, it is pointing downward. So as a result, what will be the direction of the force? The direction of the force is downward for A and B. And what is the direction of the force for C and D? It will be upward. So they're asking, state the direction of the force on AB. So what is the direction of the force on AB? That is downward. And what is the direction of the motion? How it will rotate? If I'm looking from here, how it appear? Clockwise or anti-clockwise? how this coil will rotate when AB is experiencing a downward force and CD is experiencing an upward force. So as a result, its direction of the motion will be anti-clockwise. And next part, explain why BC does not contribute to turning effect. Like why there is no force on BC, that is a question. Like we draw the direction of the force for AB, it was downward and CD is upward. But why we did not draw any force for B and C? The reason is that because the wire should cut the magnetic field. Like wire should be perpendicular to a magnetic field or making certain angle to experience a force. Because B and C does not cut the magnetic field, it is parallel to magnetic field. That's why it does not experience any force. So answer here, explain why BC does not contribute to a turning effect. So it does not, it is parallel to magnetic field. Or you can also say it does not cut the magnetic field. Because to experience a force, the wire should cut the magnetic field. So if the wire is not cutting the magnetic field, it does not experience any force.